It was a dark, stormy night on Earth, but far beyond the reach of human light, in the farthest corners of our solar system, there was an object so elusive, so mysterious, it had captivated astronomers for centuries. Pluto. This tiny, icy dwarf planet, located at the edge of the solar system, had long been a subject of fascination and speculation. Pluto, orbiting at a distance of around 40 astronomical units from the Sun, was often seen as a distant speck in the night sky. But what lay beneath its icy surface was far more extraordinary than anyone could have imagined. Pluto's orbit, a long and drawn-out elliptical path, takes 248 Earth years to complete, making it a fleeting visitor in our backyard, a world that we had barely touched, let alone understood. As we begin our journey, we first travel through the darkened void, crossing the outermost regions of our solar system to Pluto's orbit. For most of its life, Pluto has been ignored, even downgraded from planet status. But now it stood before us like a frozen enigma waiting to be explored. In 2006, the world's attention turned toward Pluto when NASA launched the New Horizons probe, a brave mission to capture Pluto in unprecedented detail. 9.5 long years it took to reach Pluto. But the images and data it returned were worth every minute of that journey. As we approach Pluto's orbit, a sense of awe settles over us. We enter the dark reaches where no sunlight touches and where temperatures are so low that even the simplest gases freeze. At temperatures reaching 60 Kelvin, far colder than the coldest winters on Earth, Pluto's surface is frozen solid. But what lies beneath is a story that challenges everything we thought we knew about the universe. The New Horizons probe, as it passed Pluto in 2015, captured breathtaking images that revealed a terrain more complex than imagined. From the heart-shaped feature, Tombaugh Regio, to the mountainous ridges that towered 6 kilometers high, Pluto turned out to be much more than a simple frozen rock. The heart-shaped area, which became a symbol of hope, was named after Clyde Tombaugh, the astronomer who first discovered Pluto in 1930. We now zoom in on the Sputnik Planitia, a vast nitrogen ice plain that stretches over 1,500 kilometers across the heart of Pluto. This region was formed around 100 million years ago after a massive collision, which opened up a crater large enough to be filled with the frozen remnants of Pluto's hypothetical inner ocean. The frozen plains glisten under the faint light of the sun, reflecting 90% of the sunlight that touches them, giving them a light-colored sheen that's almost alien in nature. But what makes this landscape so compelling isn't just the ice and the cold, but the mystery of Pluto's tectonic activity. Yes, Pluto, a world considered to be a cold, dead planet, might still have tectonic movements beneath its icy surface. Could there be more warmth inside? Is it possible that some form of life exists beneath the frozen shell? As we travel further around Pluto, we encounter a mountain range, the Hillary Monts, towering at 3.5 kilometers high, formed not from rock, but from water ice, so cold that it behaves like stone. The mountains serve as evidence of Pluto's turbulent past, and perhaps its future as well. The existence of these strange structures raises an important question. Could Pluto have once been an active world with volcanic activity and oceans? Further into our journey, we come across Cthulhu Macula, a dark spot that stretches nearly 3,000 kilometers across the southern hemisphere of Pluto. This vast dark region is one of Pluto's oldest surfaces, its dark coloration a result of exposure to the harsh conditions of space. It's a stark contrast to the bright shining plains of Sputnik Planitia, and serves as a reminder of Pluto's enigmatic history. Could this spot hold secrets of ancient processes or even interactions with other celestial bodies? With each new discovery, Pluto's mysteries deepen. But our journey doesn't end here. As we push past Pluto's orbit, we are reminded that this is just the beginning. Beyond Pluto's shadow lies the heart of the Kuiper Belt, filled with thousands of icy bodies and dwarf planets waiting to be explored. Beyond that, we'll venture toward strange exoplanets, where the laws of nature itself may defy everything we know. As we prepare to leave Pluto behind, we realize that we are standing at the threshold of a new frontier. The Kuiper Belt, a vast region stretching out beyond Pluto, is a wilderness of frozen objects and ancient remnants from the solar system's early days. As we travel through this mysterious realm, we'll encounter objects that may hold the key to understanding the very origins of our solar system, and perhaps the secrets of the universe itself. And beyond the Kuiper Belt, there's an even greater mystery: the interstellar voids. In this immense cosmic expanse, dark matter and dark energy dominate, and the very fabric of space and time may behave in ways we cannot even comprehend. But for now, as we look back at Pluto's pale blue dot in the distance, we can't help but feel a sense of awe. We have only just begun to scratch the surface of this mysterious world. What lies ahead? Only time will tell. As we venture beyond the orbit of Pluto, we leave the familiar stretches of our solar system behind. The stars seem distant, and the blackness of space envelops us like a vast, endless ocean. The Kuiper Belt, a region once thought to be a quiet, barren wasteland, is now before us, a wilderness full of ancient objects and mysteries waiting to be uncovered. Unlike the inner solar system, where planets revolve neatly along a well-defined path, the Kuiper Belt is chaotic and irregular. It stretches from Neptune's orbit beyond Pluto, all the way to around 50 astronomical units from the Sun. This region is filled with icy bodies, dwarf planets, and ancient remnants from the time when our solar system was still forming. Comets, once thought to be the harbingers of destruction, now reveal themselves as relics, frozen time capsules containing the secrets of our solar system's birth. We now approach Haumea, one of the strangest objects in the Kuiper Belt. Haumea isn't like the spherical bodies we've encountered before. Its shape is elongated, resembling a rugby ball, and it spins rapidly, completing a rotation in just under 4 hours. This fast rotation is the reason behind Haumea's unusual shape. Its gravity can't keep the body round, so it stretches out into an oblong form. But it's not just Haumea's shape that makes it fascinating. Haumea is surrounded by a ring of debris, a feature that's rarely seen in the solar system. Its surface is covered in crystalline ice, which reflects sunlight, giving it an eerie glow. The presence of water ice on its surface raises an important question: is there still some internal heat here, perhaps a remnant of Haumea's creation? As we zoom in on Haumea, we detect another unexpected feature: its moons. Haumea has 2 known moons, Hi'iaka and Namaka, both of which are surprisingly active. Hi'iaka, in particular, exhibits unusual surface features that suggest geological activity. Could there be hidden oceans beneath the icy surface of these moons? The possibility is tantalizing. What if the Kuiper Belt, far from being a cold, barren region, was home to active worlds with hidden seas, volcanic activity, and maybe even life? We don't have answers yet, but the mystery deepens as we travel farther into the Kuiper Belt. This region is not just a collection of objects. It's a dynamic environment, a chaotic realm where remnants of the early solar system still collide and interact. It's a place where the wild nature of creation still echoes, and new questions arise with every object we encounter. But there's more ahead. As we push onward, we leave Haumea behind and head toward the next giant of the Kuiper Belt, Eris. Discovered in 2005, Eris is one of the most massive known objects in the Kuiper Belt, and it's also one of the most mysterious. Eris is so far from the Sun that it receives almost no warmth. Yet despite its icy exterior, this dwarf planet has atmospheric layers made up of methane and nitrogen, similar to what we see on the gas giants. Eris orbits the Sun at a distance of 96 astronomical units, which means it's one of the most distant objects in our solar system. Its surface, made of frozen methane ice, gleams in the dim light, and its largest moon, Dysnomia, orbits it in a curious, almost perfectly circular path. Unlike Pluto, whose orbit occasionally brings it closer to the Sun than Neptune, Eris stays far out in the cold. It is a world that seems both remote and untouched by time. The surface of Eris has a dark reddish hue, a color caused by the presence of complex hydrocarbons which, along with its icy surface, give it the appearance of a frozen wasteland. But there's more to Eris than meets the eye. Some scientists believe that beneath its icy surface there could be a liquid ocean, kept warm by the planet's internal heat. As we study this distant world, we wonder, could there be something hidden beneath that ice, waiting for us to discover it? The sheer isolation of Eris makes it an unlikely candidate for life, but the universe has a way of surprising us. Could there be microbes living beneath the frozen surface, protected from the cold by the deep ocean beneath? With each new discovery, we push deeper into the unknown, farther from the Earth, farther from the stars we know. But the question persists. What lies beyond? What is waiting for us in the distant Oort Cloud, a region even farther than the Kuiper Belt? This cloud, a vast spherical shell of icy bodies, stretches out to the farthest reaches of our solar system, perhaps as far as 100,000 astronomical units from the Sun. As we cross the boundary of the Kuiper Belt, we leave behind objects like Eris and Haumea and enter the true unknown. The Oort Cloud is the last frontier of our solar system, the final barrier before interstellar space begins. Here, in the distant dark, we find objects so far removed from the Sun's influence that they have become frozen relics of the early solar system. They are cold, ancient, and locked in orbit for billions of years, untouched by the passage of time. But even here, in this frozen wilderness, there is mystery. Some objects in the Oort Cloud may have been sent here by the gravitational influence of nearby stars, and as we continue to explore, we begin to realize that this region is not just an empty space. It is a part of a much larger story, one that stretches across the cosmos and reaches beyond the limits of our imagination. And as we leave the Kuiper Belt and head toward the Oort Cloud, one thing becomes clear. We are on the brink of discovering the origins of our solar system itself. Every object we encounter, every mystery we uncover, is a clue to the formation of the planets and the birth of life. As we move toward the farthest reaches of our solar system, we know that we are not just looking at cold, distant worlds. We are looking at pieces of a puzzle, pieces that, when put together, could reveal the hidden history of our solar system. And perhaps, just perhaps, they could answer the ultimate question: are we alone in the universe? As we leave the inner reaches of the Kuiper Belt, a strange sense of awe fills the air. Distant, quiet, endless. Far beyond the familiar celestial bodies we've encountered, the Oort Cloud stretches into the darkness, a vast and frozen outer shell of icy bodies. Here, objects and comets lie dormant, drifting in the cold expanse at the very edge of our solar system, where the sun's light is but a weak glimmer in the distance. The Oort Cloud, though still largely unexplored, is believed to contain trillions of icy objects. It is so distant that it is almost impossible to detect with our current technology. The cloud is divided into two main regions: the outer Oort Cloud, which extends out as far as 100,000 astronomical units from the Sun, and the inner Oort Cloud, which lies closer to the Kuiper Belt, but still far beyond the planets. The sheer size of the Oort Cloud is mind-boggling. It could be over 50,000 times farther from the Sun than Earth, but even though it's largely invisible, this cloud is crucial to understanding the history and evolution of our solar system. As we venture deeper into this icy region, we begin to understand why the Oort Cloud is sometimes referred to as a cosmic nursery. Here, comets are born, some of them still carrying the ancient traces of the solar system's formation. They are frozen time capsules, locked in orbit around the Sun, drifting along the very edge of the solar system. Some will one day fall into the inner solar system, where they may be captured by planetary gravity, while others will continue to drift forever in the cloud's immense void. The comets in the Oort Cloud are not just frozen chunks of ice and dust. They are reminders of the very early stages of our solar system. They contain material from the time when the Sun and its planets were first forming. By studying these icy bodies, scientists hope to unlock the secrets of how the solar system came into existence. These objects are the cosmic fossils of our history, frozen in time, untouched by the changes that have shaped the planets. One particular comet that draws our attention is C-2014Q2, a bright comet that passed close to the Earth several years ago. This comet, made of water ice, ammonia, and methane, lit up the night sky with its brilliant glow. But as scientists studied it, they discovered something strange. The comet emitted a bizarre gas that they could not fully explain. It wasn't just water vapor, as expected, but something more complex, something that hinted at the possibility of complex organic molecules in the Oort Cloud, molecules that could play a role in the origin of life. Could it be that the building blocks of life were already present in the outer reaches of our solar system? The mystery of the Oort Cloud only deepens as we continue on our journey, moving farther and farther away from the sun. The vastness of this region is almost incomprehensible, and yet there are signs of activity. Scientists believe that nearby stars may influence the Oort Cloud, nudging some of its icy bodies into the inner solar system, causing them to become the comets that we observe. In fact, we can already see some evidence of this. The Sedna object, a large trans-Neptunian body, has an orbit that takes it far beyond Pluto, and its trajectory suggests that it was once part of the Oort Cloud before being perturbed by the gravitational influence of a nearby star. As we move deeper into the Oort Cloud, we encounter another mystery, the origin of the long-period comets. These comets, which take over 200 years to complete their orbits, come from deep within the Oort Cloud. Their strange and unpredictable paths suggest that they were once ejected from their original locations by the gravitational forces of the planets in the early solar system. As we study these comets, we begin to understand the chaotic processes that shape the outer solar system. But the Oort Cloud is just the beginning. Far beyond its icy reach lies the true frontier, the interstellar space that begins after the boundary of the Oort Cloud, a place where the sun's influence fades into the vastness of the cosmos. As we approach the end of the solar system, the stars in the distance seem so far away that they are little more than tiny pinpricks of light. Here, in this cold, dark void, we begin to see the limits of our solar system. This is the boundary that separates us from the rest of the galaxy, an area so vast and empty that the distances between objects are incomprehensible. As we drift farther out, we are reminded that our solar system is just a tiny speck in the grand expanse of the universe. But as we approach the edge, we are struck by the realization that the Oort Cloud is not just an isolated region of frozen objects. It is the gateway to something much greater, a connection between our solar system and the stars. We are standing at the threshold of interstellar space, the vast unknown, a place where the rules of physics and the mysteries of the cosmos await. As we leave the cold, frozen reaches of the Oort Cloud, the emptiness around us becomes almost palpable. There's no warmth here, no stars close enough to offer their light, no gravitational pull to anchor us. This is the great interstellar void, the vast, dark space between the stars that fills the galaxy. It's a place where time itself seems to slow, where the very fabric of the universe stretches out and becomes incomprehensibly vast. Here, the solar system's influence fades to nothing. The sun's light, though still detectable as a faint glimmer, is now lost in the overwhelming darkness of the void. Yet, even in this vast emptiness, there are whispers of a deeper, more profound mystery waiting to be uncovered. As we venture into the heart of interstellar space, we're confronted with the realization that this space between the stars is not empty. Far from it. This seemingly barren region is filled with interstellar dust and cosmic rays and dark matter, the invisible, mysterious substance that makes up most of the mass of the universe. While we cannot see it, we know it's there, surrounding us, permeating the very fabric of space itself. Our ship moves slowly, gliding through the darkness, navigating the vast expanses of space with a sense of awe and trepidation. We're approaching something that only a handful of explorers have ever witnessed, something that will change the way we understand the universe. We encounter a cloud of interstellar dust, a cloud that stretches across space for light years. It's not unlike the nebulae that we've encountered closer to home, but this dust is ancient, leftover from the birth of stars and planets. In this cloud, we find organic molecules, the building blocks of life. These molecules are scattered across the vast stretches of space, floating through the darkness, waiting to settle on some distant planet or icy moon. This discovery is profound. Could these organic molecules, drifting in the void for billions of years, be the seeds of life? Could they be the key to understanding how life began, not just on Earth, but across the entire universe? As we continue deeper into the interstellar void, we come upon an even greater mystery: the dark matter that surrounds us. Though invisible and undetectable by conventional means, dark matter makes up most of the mass of the universe. It is the unseen force that holds galaxies together, that dictates the motion of stars and planets on the largest scales. Yet, despite its profound influence on the cosmos, dark matter remains one of the greatest enigmas of modern science. The question is simple: what is dark matter? Why does it exist? And more importantly, how does it shape the universe in ways we still don't fully understand? To answer these questions, we must look far beyond our solar system to distant galaxies where dark matter's effects are strongest. There, we can begin to trace its influence, mapping out the invisible web that holds the universe together. As we move deeper into the void, we cross the boundary between the known and the unknown, the boundary between our solar system and the galactic environment. This is where our journey truly begins. The void stretches out before us, and we realize that beyond the familiar stars and galaxies lies an even greater frontier: the galactic halo, the region that surrounds the Milky Way galaxy. The galactic halo is a vast spherical region that extends well beyond the visible edges of the galaxy, where stars, gas clouds, and dark matter swirl in a delicate balance. In the halo, we find evidence of a phenomenon that has fascinated astronomers for decades: the presence of rogue planets, planets that have been ejected from their home star systems, wandering aimlessly through space. These rogue planets are nomads, lost worlds, drifting alone in the void, with no star to warm them, no sun to provide light. They are remnants of the galaxy's violent past, the survivors of cosmic collisions and stellar evolution. Some of these planets may still harbor life that has adapted to survive in the harshest of conditions, far from the warmth of a sun. But as we travel further into the galactic halo, we encounter something that defies explanation: a strange anomaly, an object that seems to bend the very fabric of space and time. It's unlike anything we've ever seen before. A region of space where the laws of physics break down, where gravity behaves in unexpected ways, and where time itself seems to stretch and contract. This anomaly, which we call the event horizon, is unlike anything in our current understanding of the universe. It is a place where the universe's fundamental laws break down, where the singularity of a black hole could be hiding, or where an entire star system could have been consumed by forces we can barely comprehend. As we approach this anomaly, we begin to experience strange phenomena. Our instruments flicker and fail, the stars outside appear to distort and stretch, and the very fabric of space seems to warp. It is as if we are on the edge of the universe, at the boundary between the known and the unknown, teetering on the brink of discovery. What lies beyond the event horizon? Is it a portal to another part of the galaxy, another universe entirely? Or is it simply the end of our journey, where space and time collapse into nothingness? We can't know for certain, but what we do know is this: we are standing at the edge of the infinite. The universe is vast, mysterious, and filled with wonders that we can only begin to imagine. As we pull back from the event horizon, we are left with one undeniable truth. The universe is a place of infinite possibilities, a place where anything can happen, where the known and the unknown meet, and where the future of space exploration is just beginning. And as we prepare to leave the interstellar void behind, we understand that this journey, this odyssey, is far from over. There are still countless mysteries waiting to be uncovered, new stars, new galaxies, and new worlds to discover. We are just getting started. As we move farther away from the event horizon, the sense of dread still lingers in the air. What we've witnessed has shaken us to our core. The distortion in the fabric of space-time, the bending of light, and the terrifying energy within, that anomaly. It was unlike anything any of us had ever encountered. We've all heard about black holes, the cosmic entities that consume everything in their path. But this anomaly was different. It wasn't just a singularity that devoured light and matter. It felt like space itself had been twisted, like reality itself was unraveling. The way the stars distorted, the way our instruments lost their accuracy, the sensation of time stretching in unnatural ways. It was as though we had crossed into a new dimension altogether. But we couldn't linger. As incredible as it was, as mind-boggling as it seemed, we had no answers. We were still far from home, and there was no room for curiosity if it meant risking everything. We had to push on. Yet, part of me couldn't help but wonder, what was it? Could it have been a wormhole? Or perhaps the entrance to another universe? The theories ran wild in my mind, each more bizarre than the last, but I couldn't focus on them for long. We had a mission, and we had to finish it. As we distanced ourselves from the anomaly, I began to realize that space exploration is not just about collecting data or mapping new planets. It's about encountering the unimaginable and trying to understand it. We were standing on the threshold of the universe's most intimate secrets, and all we had were questions. No answers. Not yet. Our path now led us toward the intergalactic space, where no star or celestial body in sight could offer comfort. The emptiness was so profound, so consuming, it felt like we were drifting through an endless sea of dark energy, where even the concept of time became meaningless. Here, light itself was a stranger, and the stars, though bright, were distant beacons of past realities, shining through the cosmic dark ages. This is where we found the real edge of the universe. Our instruments began to register strange readings. They flickered and buzzed as if they were being overwhelmed by some unseen force. But we kept pushing forward. The vastness of intergalactic space stretched before us, and we knew that if we continued this journey, we might come to understand something fundamental about the universe itself. In the distance, we spotted something strange, an intergalactic void. It was a dark zone where no light seemed to penetrate. It wasn't a black hole or a nebula. No, this was something else entirely. This was an area where gravity was weak, and the cosmos itself seemed to stop moving. In this place, matter as we knew it seemed to dissolve into pure darkness. But as we approached the void, something incredible happened. A flash of light, bright, sudden. It wasn't a star, a comet, or a nebula. It was a pulse, a wave of energy, unlike anything we had seen. It swept through the void, spreading outward and lighting up the space around us in an otherworldly glow. The pulse seemed to be alive, an entity in itself. Our sensors went haywire. Readings became distorted, blurred, incomprehensible. Yet, through the confusion, we saw a pattern. The pulse wasn't random. It was a message, encoded in energy. But what did it mean? Who sent it? In that instant, we realized we were no longer alone in the vastness of space. This was the moment when we understood that space exploration is not just about charting new worlds. It's about making contact with something greater, something beyond human comprehension. We had passed through the doorway into the unknown, and the universe was responding. Final part. The message, a new dawn for humanity. As the pulse of energy settled into the vast void, everything changed. The stars flickered in the distance, but they no longer seemed like distant pinpricks in the dark. The galaxy itself began to feel alive, connected by invisible threads of energy. For the first time in this journey, we felt the weight of what we had discovered. The pulse, the message. It was not a warning. It was an invitation to understand, an invitation to join. The very fabric of space seemed to be interwoven with information, like a giant cosmic web, and the pulse had reached out to us, pulling us into its embrace. It wasn't just an alien message, though. It was cosmic knowledge, a doorway to something beyond, something older than the stars themselves. Our ship, once a solitary vessel in the cold depths of space, now felt like a tiny node in the vast expanse. We were connected, not just to each other, but to everything. The pulse had opened our eyes to the universal truth. We are part of something much, much greater. The question of whether life existed beyond Earth had always been asked by humanity, but now we knew the truth. Life was not isolated to our planet. It was woven into the very fabric of the universe, and we had just touched the tip of the iceberg. The pulse wasn't just a communication. It was an invitation for us to explore, to learn, to connect with civilizations and entities across the cosmos. As we continued our journey back toward Earth, we understood that humanity had entered a new era, an era where we were no longer alone, no longer isolated in the dark void. We were part of a much larger cosmic network, and this discovery would shape the future of our species. But this was just the beginning. The universe was vast, ancient, and full of unimaginable wonders. The questions we had asked, the mysteries of the stars, the strange energy pulses, the existence of other life, had only just begun to be answered. The pulse we had received was a sign. A new dawn for humanity, where the boundaries of space no longer confined us, and the unknown was no longer a threat, but a challenge. In the end, we realized that the universe was far more connected than we had ever imagined. And as our ship neared the familiar blue glow of Earth, we knew that the world would never be the same. We had ventured into the unknown, and we had returned not with just answers, but with a future, the end.